Hello! Now we're getting into the second half of Unit 6. The second half of Unit 6 deals with solving. We are still going to be dealing with factoring, but now that you know how to factor, it'll make solving that much easier.
So we have to know some key vocabulary for this particular point 4. So we have zero of a function, root of an equation, zero product properties. So we have to understand what zero of a function is. It states this: a value for x that makes the output of f of x equals 0. The x-intercepts of the graph, quadratic functions can have 2 zeros.
Can is the key word. You might have one, you might have none. We're not going to be dealing with the none situation right now. We'll talk about that in Unit 7. And you can have one, which we will sometimes see that. We'll talk about what that looks like.
So then we have root of an equation, which states a value for x that makes the equation true. We use the zero product property, or ZPP, to find the roots.
So one thing that we want to stress is that if you hear us use zeros, roots, or x-intercepts, these all mean the exact same thing. So we will be using them interchangeably. Know that, because it varies from who's writing questions and who's not in terms of MCAs, ACT, etc. So you need to know that they all mean the same thing.
So then last but not least, we have the zero product property, which states that if parentheses x minus a parentheses times x minus b equals 0, then either x minus a equals 0 or x minus b equals 0.
And you guys learned about the zero product property before, that it just simply means that if you multiply two things together to get 0, one of them has to be 0, because otherwise you won't get 0 for an answer. So let's get into some examples. We have f of x equal to 3x plus 2 times x minus 4. The first thing we want to do is change the f of x into 0, because we want to find your roots or zeros, which means I want to know what does x equal when y is 0. And simply that means by my zero product property that either 3x plus 2 equals 0 or x minus 4 equals 0. And then from here we just solve. So we subtract 2 and we get 3x equals negative 2, and then we divide by 3. And please, 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 please leave these as fractions. Don't try to get decimal answers. It doesn't make any sense. So we get x equals negative 2/3. That means we have to write our first 0 as negative 2/3, comma 0. I will not accept it just as x equals negative 2/3. For the other one, we need to add 4. And when we add 4, we get x equals 4. That means that my 0 is going to be 4, 0. Pretty straightforward. That's our first type of problem. The next type is when it is not already factored. So the first thing we're going to do is set the function equal to 0. Then we're going to factor it, and then we'll set up our factors to 0 to solve for x. So it's really just one extra added step. So I start with saying 0 equals x squared plus 2x minus 3. It's a trinomial with 3 terms, and I see a coefficient for a as being 1, which means I'm going to do a t-table. That means I need to multiply to negative 3 and add to 2. Well, 3 is nice. I need to multiply to a negative. I need to add to a positive. So I know that it's going to be 3 times negative 1, because that will give me 2. That means that when I factor this, I get x plus 3 times x minus 1. Now I can go ahead and set them each equal to 0. So I've got x plus 3 equal to 0, or x minus 1 equal to 0. Go to solve these, so I'll add 1 here, and I get x equals 1. And here I subtract 3, and I get x equals negative 3. That means my zeros are negative 3, 0, and 1, 0. So once again, still pretty straightforward.
A reminder, we need to see the t-table and all of this work to give you full credit.
Yes, because some of you may have noticed that if you've got the right answer but there's no work shown, I take -1 off for having no work shown, just so you know. Here, we set it equal to 0. First thing that I know I need to look for, I see they all have x's in them, so I'm going to factor out an x. So that means I have x times x squared plus 2x minus 48, still equal to 0. Then I see that right here, we have a trinomial, we can use a t-table, so I need to multiply to negative 48, and I need to add to a positive 2. So if I need to add to a positive, it means my bigger number is positive, so we got 48 and negative 1. We've got 24 and negative 2. We got 16 and negative 3, 12 and negative 4, and 8 and negative 6. And I look here, this is 47, this is 22, we got 13, 8, and 2. So we know that we still have the x out front. We have x plus 8 and x minus 6. Now one thing that I will give you a hint for is the highest degree exponent will tell you how many zeros. So that means here I've got 3 different pieces. That means x can equal 0. Oh, that one's already solved for us. X plus 8 equals 0, or x minus 6 equals 0. When I go to solve these, I add 6, subtract 8, and I get x equals negative 8, x equals 6. That means now I'm going to have 3 of them. I've got 0, 0. I've got negative 8, 0. And I've got 6, 0. I realize that these aren't quadratics, but you should be able to find these zeros. The next one, I got numbers on both sides. So that means first, I'm going to subtract 49x to get it over to the other side, which means now I've got x cubed minus 49x equal to 0. First, I'm going to factor out an x, because they both have x's in them. And I'm left with x squared minus 49. Then I realize, well, x squared minus 49, those are both perfect squares. Square root of x squared is x. Square root of 49 is 7. So that means that I still have the x out front. Now I've got x plus 7, x minus 7 equal to 0. So now I've got the options of either x equal to 0, x plus 7 equal to 0, and x minus 7 equal to 0. So here I add 7 to get x equals 7. Here I subtract 7 to get x equals negative 7. That means my 3 zeros are 0, 0, negative 7, 0, and 7, 0. The next one. First we turn this into a 0. And then I see I have 4 terms, which means I need to factor by grouping. So the first one, I can factor out an x squared, and that leaves me with x minus 4. I want an x minus 4 here, so I'm going to factor out a minus 3. And therefore now I've got that 0 is equal to either x minus 4 or x squared minus 3. So now I set these both equal to 0. So x minus 4 equals 0 and x squared minus 3 equals 0. Here I add 4 and I get x equals 4, which means that my 0 is 4, 0. Here I add 3 to get x squared equals 3. Then I have to square root, which means I get x is equal to plus or minus the square root of 3. This here told me that I have 3 zeros, so that means I have the square root of 3, 0, and negative square root of 3, 0. Some of you want to know probably right now, can you just put those as one ordered pair? No, you cannot. You have to separate them out. Finally, I wanted to show you this one because this is a great example of something that you will see in the future, but I want to make sure you're exposed to it now. Some of you are going, oh my gosh, it says x to the 4th. That means I have 4 zeros. You haven't seen something like this, but the nice part is when you have ax squared plus bx plus c, this x is to a power 1. 1 is half of 2. Here, 2 is half of 4, so it works in the same fashion. So you will do a t-table. We want multiplies to 3, adds to negative 4. If I need to add to a negative, that means both of them will be negative. So I've got negative 3, negative 1, because that gives me negative 4. So when I break into my binomials, I have minus 3 and minus 1. To get x to the 4th, I get x squared and x squared. Well, here's the thing. First off, I recognize that these are both perfect squares. Square root of x squared is x. Square root of 1 is 1. That means that my final breakdown is going to be x squared minus 3 times x plus 1 times x minus 1. This way, some people are going, well, why can't I just take x squared minus 1, set it equal to 0, and solve and get plus or minus 1? Absolutely. But the problem we run into is the number of you that are still forgetting that when you square root a number, that you get 2 answers. So it's easier if you break it down first. So now we've got that x squared minus 3 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Well, we learned in the last example that we would add 3 and then square root, which means you get x equals plus or minus the square root of 3. Here you subtract 1, here you add 1, and you get x equals negative 1 and x equals positive 1, which means that my 4 zeros are square root of 3, 0, negative square root of 3, 0, 1, 0, and negative 1, 0. And I know that seems like a lot. You will not get examples like that in your homework or on the standard checks or on the test, just as an FYI. So now, I've got 3 problems for you to try. First one is already factored. Second one, you'll have to factor out. I'll give you a hint. It is not AC method. And the third one is just a simple t-table. Go ahead and bring your questions with you to class tomorrow.